Arduino is a microcontroller platform that acts as the brain of electronic projects. It processes instructions and controls components like motors and LEDs, transforming ideas into functional electronics. This programmable core is essential for directing actions and making concepts a reality in the world of electronics. The Arduino microcontroller functions as the central processing unit or brain of electronic systems, playing a pivotal role in managing and coordinating various hardware components. Essentially, Arduino is a compact, programmable device capable of executing code that dictates the behavior of connected elements such as motors, sensors, LEDs, and other electronic modules. Much like the human brain interprets and responds to stimuli to regulate bodily functions, the Arduino interprets input from the environment, e.g. through sensors, and responds by triggering appropriate outputs, e.g. activating an LED or rotating a motor. This process allows designers and engineers to transform abstract concepts into practical interactive devices. By writing and uploading code through the Arduino Integrated Development Environment, IDE, users define the logic and sequence of operations the microcontroller must follow. Consequently, Arduino serves not only as a control hub but also as a powerful tool for prototyping, experimentation, and learning in the fields of robotics, automation, and embedded systems. Arduino represents an accessible entry point into the world of electronics and programming. As an open-source microcontroller platform, it is specifically designed to lower the barriers for beginners while still offering the depth and flexibility required by more advanced users. Its intuitive interface and simplified programming language allow individuals with little to no prior experience to begin developing electronic projects with ease. A key strength of the Arduino ecosystem lies in its extensive and active global community. This collective support network offers a wealth of tutorials, forums, example projects, and open source code, greatly enhancing the learning experience and enabling users to overcome challenges collaboratively. Moreover, Arduino fosters innovation and creativity by allowing users to design, prototype, and iterate on their ideas rapidly. Whether creating interactive art, building DIY home automation systems, or exploring robotics, Arduino empowers hobbyists, students, and educators to experiment and learn in a hands-on, engaging way. As both an educational tool and a prototyping platform, Arduino effectively bridges the gap between conceptual understanding and practical application, making it a foundational technology for aspiring engineers and makers alike. Arduino's versatility extends far beyond simple hobby projects, finding practical application in a wide range of real-world scenarios across diverse fields. In smart home automation, Arduino serves as the control center for systems that manage lighting, temperature, motion detection, and other sensor-based functionalities. This allows for increased convenience, energy efficiency, and personalized user experiences within domestic environments. In the field of robotics, Arduino is frequently employed to control the movement, behavior, and sensory processing of small-scale robots and drones. Its ability to integrate multiple input and output components makes it ideal for enhancing robotic responsiveness and precision. Artists and designers have also embraced Arduino as a tool for creating interactive installations and kinetic sculptures. By embedding sensors and actuators, artists can develop dynamic pieces that respond to touch, motion, light, or sound, blurring the line between technology and creativity. In the rapidly evolving domain of wearable technology, Arduino plays a crucial role in powering smart clothing and accessories. These devices often incorporate sensors for health monitoring, motion tracking, or environmental interaction, enabling innovative applications in fashion, fitness, and healthcare. Together, these use cases underscore Arduino's adaptability and impact, demonstrating how a simple microcontroller platform can drive innovation across disciplines and transform abstract ideas into tangible functional technologies. Arduino offers a wide range of microcontroller boards, each tailored to meet specific project needs and user expertise levels. This diversity allows makers, educators, and engineers to select the most appropriate board for their intended application, optimizing both functionality and design efficiency. The Arduino Uno is the most widely used and beginner-friendly board in the Arduino family. Featuring a straightforward layout and a robust set of input-output I/O pins, it is ideal for introductory projects and educational use, offering a reliable foundation for learning embedded systems. For space-constrained applications, the Arduino Nano provides similar capabilities in a significantly smaller form factor. Its compact size makes it well suited for miniature projects such as custom sensors or embedded modules in tight enclosures. When more complex systems require additional connectivity, the Arduino Mega stands out with its expanded I/O capabilities. With over 50 digital pins and multiple serial communication ports, it supports large-scale projects such as 3D printers, advanced robotics, or data acquisition systems. The LilyPad Arduino, designed specifically for wearable electronics, introduces a unique blend of technology and textile. Its flexible, washable design enables seamless integration into clothing and fabric-based projects, empowering creators to develop smart garments and e-textiles with interactive features. Each of these boards exemplifies how Arduino's ecosystem supports a wide spectrum of innovation, making it possible to match the right hardware to the unique demands of creative and technical endeavors. Gaining a foundational understanding of Arduino begins with recognizing and comprehending its essential hardware components. These elements collectively enable the board to interact with software, receive power, and control external devices. One of the most critical features is the Universal Serial Bus USB port, which serves a dual purpose. It allows users to upload code from a computer to the Arduino board and simultaneously provides power during development and testing phases. This interface forms the primary communication link between the board and the Arduino Integrated Development Environment (IDE). Another key component is the power jack, which enables the Arduino to operate independently from a computer by accepting external power sources, typically ranging from 7 to 12 volts. This is particularly useful when deploying projects in real-world untethered scenarios. The digital and analog pins are crucial for input and output operations. These pins allow the Arduino to read signals from sensors, inputs, and control actuators like LEDs or motors, outputs. Understanding the distinction between digital on-off signals and analog variable signals pins is essential for building responsive and interactive systems. At the core of the board lies the microcontroller, which acts as the central processor. This programmable chip executes instructions, processes data from sensors, and dictates how connected devices should behave. It essentially embodies the logic of your project. Familiarity with these core components provides a strong starting point for working with Arduino, empowering learners to explore more complex circuits and code with confidence. Arduino functions as the central processing unit or brain of countless electronic projects, providing a programmable platform that enables users to translate conceptual ideas into functioning prototypes. Its accessible design and intuitive programming environment make it especially well suited for beginners, while its modular capabilities support increasingly complex applications. A defining strength of the Arduino ecosystem is its robust global community. This network of hobbyists, educators, and professionals contributes an ever-growing repository of open-source libraries, tutorials, and troubleshooting forums, significantly lowering the barrier to entry for new learners and facilitating continuous development for experienced users. Arduino's adaptability is evident in its wide range of applications, from smart home systems that automate lighting and sensors to educational robotics, interactive art installations, wearable electronics, and IoT devices. Arduino serves as a flexible foundation for innovation across disciplines. Supporting this versatility is a diverse family of boards such as the Arduino Uno for beginners, Nano for compact projects, Mega for complex systems, and LilyPad for wearable technology, each tailored to specific project requirements. This range empowers users to select the most suitable hardware for their design goals, enhancing both efficiency and creative potential. Overall, Arduino represents an essential tool in modern electronic design and education, merging hands-on experimentation with digital logic, in a way that inspires innovation and technical fluency. To effectively utilize Arduino in electronic projects, it is essential to understand the physical and functional layout of its core components. Each element on the board contributes to its overall capability to control and interact with external devices. Microcontroller. At the heart of the Arduino board lies the microcontroller, typically an Atmega series chip. This component is responsible for executing programmed instructions, processing input data from sensors, and managing output signals to control actuators. Power supply system. The board includes multiple power options. The DC power jack accepts external voltage sources, usually 7 to 12 V, while the USB port supplies power when connected to a computer. Digital and analog I/O pins. Digital pins, usually numbered 0 to 13 on an Arduino Uno, can read or write binary signals, high or low, making them ideal for controlling devices like LEDs or reading digital sensor input. Analog pins, typically A0, A5, are used to read varying voltage levels from analog sensors, enabling more nuanced data input, such as from temperature or light sensors. Universal Serial Bus USB interface. This port facilitates two main functions. It allows code to be uploaded from the Arduino IDE on a computer to the board, and it also serves as a power source during development and testing. Reset button. This button restarts the program running on the microcontroller, which is especially useful during debugging or when changes are made to the circuit or code. Voltage and ground pins. These pins, e.g. 5V, 3.3V, G and D, provide reference voltage and grounding connections for external components, forming a reliable power distribution network within the project. A clear understanding of these components is foundational for successful project implementation. It allows users to troubleshoot, expand, and innovate with confidence as they build increasingly sophisticated systems using Arduino.